So in this video, I'm going to discuss case number 3 of trigonometric substitution. So case 3 is when the integrand contains an expression of the form square root of u squared minus a squared, with a being greater than 0. And again, we'll introduce a new variable theta by letting u equal to a secant theta. So let's have this illustration. Evaluate the integral of dx over 4x plus x squared. So take note that the denominator or the radicand, this radicand, the term under the radical sign, is not in the form u squared minus a squared. So what we are going to do is to convert this one into this form u squared minus a squared. So every time you will encounter this one, you have a second degree term, a first degree term. Think of a perfect square trinomial. Therefore, you need a constant term to make it a perfect square. Therefore, for this one, we will use completing the square. Okay, so let us rearrange this one from 4x plus x squared to x squared plus 4x. So to have a perfect square trinomial, we need a constant term. So again, to review, to get the constant term, all you have to do is to divide the coefficient of the second degree term by 2, and then you square it. So 4 over 2 is 2 squared, you have 4. So you will add a third term. So like this now. You add a third term para these three terms will now be a perfect square trinomial. But then sa completing the square, whatever number you add, same number will be subtracted also. So you subtract na to 4. So that in effect, 0 lang. No changes at all. But after this modification, this will result to this one. X plus 2 squared minus u 2 squared. Therefore, the original radicand 4x plus x squared converted to this one conforms to this form u squared minus a squared. So this original integral can be written as this one, square root of x plus 2 squared minus 2 squared. And so we can use the substitution, u equal to a secant theta. So this is our u, x plus 2, our a, 2 secant theta. Differentiate the x. Derivative of secant is secant tangent. And then get the expression of secant, x plus 2 over 2. And then you draw the triangle, theta. Secant is opposite, reciprocal of cosine, adjacent over hypotenuse. Therefore, secant is hypotenuse over adjacent. So x plus 2 is hypotenuse, 2 is adjacent. And the opposite side is square root of this one, squared minus 2 squared. So we already have secant theta. Next, we have tangent. Tangent theta is square root of this one over 2. And cross multiply, we have this. So let's substitute. dx is 2 secant theta tangent theta d theta, while square root of x plus 2 squared minus 2 squared is simply 2 tangent theta. Cancel. Cancel ang tangent and then 2 also. So what remains is secant theta. Integral, this is a standard form. So the integral of this is ln of secant plus tangent. And then you can substitute secant theta by this one, x plus 2 over 2, as well as tangent theta, this one. Now, this is similar to a problem in case 2, wherein the denominator can be combined. You can factor out 1/2, this one. And again, same with the problem in case 2, using a property of logarithm, that for ln of xy, it can be written as ln of x plus ln of y. And then constant plus another constant combined is equal to a constant again. Okay, so this is our final answer. And another one, evaluate integral of dx over 4x squared minus 9 raised to 3 halves. So this is in the form u squared minus a squared. 4x squared equal to 2x quantity squared, u and a. So let u equal to a secant theta. So derivative of 2x is 2 dx. Derivative of secant is secant theta d theta. A secant theta tangent theta d theta. So secant theta 2x over 3 triangle hypotenuse over adjacent. And opposite side is this one. So we have tangent theta, so we'll get the expression of tangent theta. Opposite over adjacent, cross multiply, we have this. So to substitute, okay. Now this one can be written as, let's extract 1/2 and transform it to radical form. This is the result. Because square root of this one, 2x squared minus 3 squared, if you transform this to exponential, this is equal to 2x squared minus 3 squared quantity raised to 1/2. Kaya square root man. So 1/2 times 3. So law of exponent would result to 3 halves. And so we can now substitute dx replaced by this one, 3 secant theta tangent theta d theta all over 2, while this one, square root, is replaced by 3 tangent theta and then cube. Okay, so let's cancel 1 tangent theta and 1 3 sa denominator. So what is left sa numerator is secant theta lang. 2 will become a denominator, and then sa denominator we have 3 tangent theta squared. So 3 squared is 9, and then 1/2 you have 1 over 18 secant theta over tangent square theta. And then let's use the expressions of secant and tangent. Secant theta is 1 over cosine. Tangent theta is sine over cosine. This is the result. So let's cancel 1 cosine. So the remaining cosine theta can be transferred to the numerator. And the result is this. And you can solve this one by changing the variable. Let u equal to sine theta du cosine theta d theta. So the result is this. 1 over 18 du over u squared, ordinary power rule. And the integral of u raised to negative 2. And then once I integrate, negative 1, u raised to negative 1 over negative 1. And 1 over 18 times negative 1, it's negative 1 over 18. U raised to negative 1 is 1 over u. And our u is sine theta. 1 over sine is cosecant. So we can write this one as negative 1 over 18 cosecant theta plus c. So if you're going to recall a triangle for this problem, okay, this is the triangle. So cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. Therefore, cosecant is hypotenuse over opposite. So to replace this one, let's substitute this one sa final expression. So 2 times 1 over 18 becomes 1 over 9. This is the final answer. Negative x over 9 square root of 4x squared minus 9 plus c. Okay, so that's case number 3. So every time when you will encounter problems similar to a form, then use the substitution u equal to a secant theta. Okay, thank you for watching.